interest rate calculator that we used in Module 2. I've taken the liberty of introducing column E, a period of repayment in years. If you remember the macro, you had to define at the outset which row of data you wish to process. This is with the line row num equals 6. Then all the manipulations were performed on that row's interest rate and on that row's loan value, and the outstanding balance was outputted into that row. Suppose we wanted to process all of rows 2 to 6 in one fell swoop. To do that, we need what is called a for next loop. What we say is that for row num equals 2 to 6, do the following, where the following will be every line of code that you've written until you reach the instruction next row num. Therefore, row num will now increment from 2 to 3 to 4 to 5 to 6 and calculate the outstanding balance for each row in turn. If we press play, you can see it works. We can make the tool even more useful by ensuring that all changes occur each and every time the spreadsheet is changed. That's done by using the notation private sub worksheet change by val target as range, as we described in Module 3. Remember, you will need to disable events at the start of the macro in order to avoid any potential perpetual unwanted loops within the data which stop the routine reaching conclusion. Events need to be enabled again at the end. So we now have a greatly enhanced interest rate calculator where if we change an interest rate in, say, row 5, the outstanding balance will change in D5 but in none of the other cells. If you can remember back to Module 2, you will be aware that this code we've written is very repetitive. These two lines calculate the outstanding balance after year 2. These two lines calculate the outstanding balance after year 3. They're virtually identical. They just take different inputs to give a different output. So what we can do instead is to create a second loop which loops from year number 2 to year number 5 and repeats the same set of calculations for each year. That means that the outstanding balance that you input into year 3 has to be equal to the outstanding balance that you've taken out of year 2. Therefore, we should no longer refer to outstanding 2. It should become the same variable here as here to ensure that the same numbers are being fed back into the calculator as have been taken out. For clarity's sake, it's probably worth renaming no repay 2, which was supposed to represent the balance which had accrued interest after year 2 with no repayments, just to no repayments. We can then delete the individual rows of instructions that calculate the outstanding balances for years 3, 4 and 5. We should note that at the end, the outstanding balance after 5 years will now be called outstanding and not outstanding 5, so we will need to change that bit of code. It's worth checking the spreadsheet still works, so if we reduce the interest rate in B5, none of the cells other than D5 should change, and this is observed. We have just created a loop within a loop. This can get very confusing. If you had 3 or 4 loops within each other, you wouldn't know which loops you were within. Therefore, each time you create a new loop, it is good practice to select the entire loop and press Tab. That marks it out from the rest of the code. So when we have a loop within a loop, it appears further out within the code module than the earlier loops do. We also want to calculate the total period of repayment for each loan. This can be done with a different type of loop. This is a do loop. This means keep going round a loop until you're told otherwise. This is best demonstrated with a practical example. In this case, we want to carry on calculating the outstanding balance on a loan until it becomes negative, because that signifies that the loan has been fully repaid. So as long as outstanding is greater than 0, we need to keep taking repayments off and adding interest on. Instead of ending with a next line, the area covered by a do while loop is bounded by the command loop. So at this stage in the code, we've calculated the outstanding balance after 5 years. We can take the code from earlier, and if we copy and paste it into our loop, we can expect to calculate the outstanding balance for years after that. However, we also want to keep track of which year we're in. So when the loop starts, we're in year 5, and we're going to be in year 6 when we exit the loop. Therefore, each time we go through the loop, we need to add a number to year num. We also need to specify that year num is 5 before we enter the loop in the first place. So we'll keep recalculating the outstanding balance until such a time as it's negative, at which point the loan has been repaid. And we know how many years that is because we've kept track of it in year num. We need to give it as an output. It will go in column E, so cells row num 5 has to equal year num. With any macro, you have to test it and see if it gives a sensible result. So let's put in an interest rate of 10% in B5 to trigger off the macro. We are now handed periods of repayment for all the loans. However, there is one issue. The period of repayment for the loan in row 6 is almost certainly less than 5 years, as the outstanding balance goes to minus $400,000 after that period. The problem is very clear in our code. Here we've said that year num equals 5. We've then said if outstanding balance is greater than 0, keep adding to year num. However, if the outstanding balance is already below 0, we just ignore this loop and toddle straight through to the answer, which says you should enter year num in column E, which will of course default to the value 5. This means we need something else in the code that enables us to skip sections of the code if the outstanding balance is already negative after 5 years. This is known as an if statement. Very simply, if outstanding at any stage is less than 0, then you should skip a section of the code. The notation is go to, and then you define the point in the code that you want to go to. So go to skip section would be one way of writing the code, where skip section skips the user straight down to the end of the macro. That means that in whatever year the loan goes negative, you immediately skip to the end of the macro and just publish the result as the period of repayment. This can be demonstrated again by changing the sheet. The period of repayment now comes out at 2 years. However, the outstanding balance is still negative when the outstanding balance should be 0 after 5 years. Therefore, we can extend this if statement here to say that if the outstanding balance is less than 0, then enter in column D 0. If you want to contain multiple lines within an if statement, you need to close the area with the statement end if. So anything which happens between here and here will only happen if the outstanding balance is negative. This means we want to make cells row num 4 equal to 0 if there's a negative balance. And then we should skip section so we can enter the period of repayment. Note that the go to skip section line has to come after we've put the balance of 0 in column D, because otherwise we would skip the line of code telling us to put 0 in column D. So again, a simple change to the spreadsheet shows that we now get an outstanding balance of 0 and the correct period of repayment. For loops, do loops, and if statements, this one, and this one, are key to creating complex Excel macros that enable you to process a vast amount of data very quickly.